and what all the different types of gallium arsenide devices I can fabricate. So mainly gallium arsenide is used in the development of MMIC. MMIC means monolithic microwave integrated circuits. Mostly gallium arsenide is used at very high frequencies in the microwave region. Monolithic, na, it is made of a single substrate. As you know, all the gallium arsenide devices can be made on a single big wafer, correct? So monolithic means it is made of a single substrate, and it is predominantly used for manufacturing microwave integrated circuits, for manufacturing integrated circuits which are used in the microwave frequency region. See, anything above 1 gigahertz is going to be microwave. So all your satellites, DTH, all your microwave oven, they are all operating in the microwave frequency. Okay. Remember, anything about 1G, 1 gigahertz, 1 into 10 power 9 hertz is going to be falling in the microwave region. Because of this suitability of high frequency transistors and low passive components, gallium arsenide is going to be the main contender for fabricating devices which are going to be used in the microwave or high frequency region. And gallium arsenide has two advantage over silicon. Why we are not using silicon at high frequencies? Why I am using gallium arsenide at very high frequencies? The reason is, one, the saturation drift velocity. The silicon is going to have a low mobility. Okay, silicon is going to have low mobility and the velocity is also less in silicon, but that is very much high in gallium arsenide. That is one reason. Second reason, it is the gallium arsenide can be made with a high resistivity. That's what the single substrate I told you can make multiple gallium arsenide devices, right? That single substrate is going to have a very high resistivity. So damage will not happen to your circuit because when the resistance is going to be high, the current flow is going to be very, very minimum. Power dissipation is also going to be very, very minimum. So two points which favor gallium arsenide over silicon. One is mobility is very high for gallium arsenide and the drift velocity is very high for gallium arsenide. It is not for gallium arsenide, it is for electrons inside the gallium arsenide. You have to interpret it like that, okay? Second point, when you are going to fabricate gallium arsenide based devices, you are going to fabricate them as a bulk. When you take a bulk semiconductor, the resistivity is very high. So inherently, the material will have very high resistivity. When the resistivity is very high, the current consumption will be less, power dissipation will be less, the device will be more safe, and the device will not be going into unstable regions. So all these are avoided when you are going to use gallium arsenide as the technology over silicon. So there are many gallium arsenide based devices which are used. One is mainly radio frequency into RFICs. The RFICs are used at very high frequencies, and MMIC in microwave. So microwave specific band use panna, you call it as MMIC, but anywhere above 1 gigahertz I'm going to call it as RFIC, or radio frequency integrated circuits, including what are those devices? Gallium arsenide MESFET, gallium arsenide HEMT. HEMT is high electron mobility transistor. Okay, gallium arsenide HBT, high by a heterojunction bipolar transistor. So these three different types of devices are possible using gallium arsenide. One is MESFET, HEMT, and HBT. These are very commonly used devices in high frequency applications in electronics and communication.